Assalamualaikum and hi, we are from Group RS 105B and our supervisor is Dr. Siti ZULAIKHA binti Muhammad YUSOF. We would like to welcome the panelists and all the viewers to our presentation. So today, we are going to present our diploma mini project that is bouncing ball experiment, analyzing the impact of pressure, material composition and temperature of the balls on its bounce height and how they are related. Before we start, this is our group members. This is the outline that we will present after this.
The bouncing ball is a basic experiment that influenced by pressure, material composition and temperature. Kelly stated that the dynamic properties of sports ball, such as tennis ball, baseballs and balls, depend on temperature. This shows that the environment's temperature affects the ball's material composition and the bounce height. The objective of the study is to study how varying internal pressure affects the bounce height of the different types of balls, focusing the relationships between pressure and elasticity, to analyze how the material properties of a certain type of balls react to the bounce characteristic, identifying which materials provide the highest coefficient of restitution, to determine the impact of temperature changes on the bounce height of different types of balls and the correlation between temperature and elastic properties, and to analyze the relationships between pressure, material composition and temperature, and how these factors influence the overall bounce performance of different balls. The problem in the study is how the effect of differing internal pressure of the ball against the bounce height of different types of balls, how the material composition of the ball reacts to the bounce characteristic, and how does the temperature of the ball affect the bounce height of the balls made from various materials. We hypothesize that the bounce height of the ball increases as the pressure of the ball increases. This is because the gas molecules inside the balls absorb more kinetic energy. As a result, the balls will undergo deformation in short period. As the balls compress, the material of the ball expands temporarily and converts from potential energy to kinetic energy, hence causing the ball to rebound higher. Other than that, we also hypothesize that the material composition of the ball is affected by different temperature. When the temperature rises, the material of the ball expands because their atom gains kinetic energy. Consequently, the ball will become more elastic and the stiffness of the ball decreases. In contrast, the stiffness of the ball increases as the ball becomes less elastic when the temperature falls. This is because the material of the balls contracts as their atom loses kinetic energy, which causes them to become closer to each other.
Now, I will present the next part, which is the literature review. This review summarizes and analyzes existing research in this field. The focus of this review is to explore the relationship between pressure, material composition, and temperature of the environment with the ball bounce height. Let's go to our first focus, which is the pressure and bounce height. Increased internal pressure in a ball generally results in higher bounce height. A research by Osman and Kim indicates that as the air pressure increases, the coefficient of restitution also increases. Maiden has also suggested when the air pressure is higher, the ball will have greater potential energy because the ball will compress more upon impact. When the pressure is optimized, the potential energy is released more efficiently and will deform once the ball touches the ground because the kinetic energy is converted to elastic potential energy. Conversely, lower air pressure will reduce the bounce height although there is no change in the ball structure. This is the graph of pressure against the coefficient of restitution that was suggested by Osman and Kim. Our second focus is the material composition. The material composition of a ball have a great significance on its bounce characteristics. Different materials exhibit distinct elastic properties that determine how they deform and recover during a bounce. A study from Andrade has found that the rubber and rubber-based materials reinforced with synthetic fiber can exhibit hyperelastic material properties. This type of materials will make the ball able to undergo large elastic strains while maintaining their characteristics. Lastly, the temperature. Temperature significantly affects the bounce height of a ball. Changes in temperature can alter the air pressure inside the ball that may result in overinflation of the ball. Potts has suggested that when the temperature increases, the elasticity of the ball also increases as the bonds inside the ball can move freely and stretch more. It allows the ball to bounce higher according to kinetic molecular theory. By understanding this, we can optimize the ball performance in different environmental conditions. Now, we will move to the third part of this presentation, which is the methodology. In this experiment, we used 4 types of ball, which is tennis ball, soccer ball, netball, and volleyball. This project uses the experimental, quantitative and qualitative methods. Firstly, we set up the temperature conditions for the environment and the balls. There are two temperatures, which is indoor, which is inside the air-conditioned room, and outdoor, which we conducted during the hot day. For each balls, we allow them to acclimate to the environment temperature for at least 13 minutes. Then, we tested each of the balls in 6 trials to ensure the reliability of the results. For the quantitative method, we measured and collect the ball's height of each ball in meter, then we tabulate it like the table shown in the slide. While for the qualitative analysis, we collect the data of the material compositions of the balls to understand how each material might contribute to its bounce characteristics. After collecting the data, we focused on two main analysis techniques, which is the average bounce height and the average bounce efficiency. For bounce height, we calculated the average bounce height for each ball type and analyzed how it changed based on the different temperatures and pressures. For average bounce efficiency, we compared the bounce efficiency across all trials to determine how well the balls retained their bounce energy under two different temperatures.
Hi, my name is HANANI. These are the results that we got from our experiment to analyze the impact of temperature and pressure on the bounce height of various balls for quantitative analysis. This is the result for table 1 indoor temperature. The average bounce height for tennis is 0.79 meter. The bounce efficiency for tennis is 52.7%. The average bounce height for soccer is 1.06 meter. The bounce efficiency is 70.7%. For netball, average bounce height for it is 1.16 meter. The bounce efficiency is 77.3%. The volleyball, the average bounce height for it is 1.14 meter. The bounce efficiency is 76%. The drop height that we use for this experiment is 1.50 meter. These are the calculations to get the value of average bounce height and the value of bounce efficiency. In order to get the value of average bounce height, we have to add all 6 trials each of the balls and divide by 6. To get the value of bounce efficiency, apply this formula in the calculation, which is average bounce height divided by drop height multiplied with 100%. And this is the result that we got from the calculation. These are the graphs based on table 1. The first graph is average bounce height versus types of ball for indoor temperature. The second graph is bounce efficiency versus types of ball for indoor temperature. Next result in table 2 of the temperature. For tennis, average bounce height is 0.85 meter. The bounce efficiency is 56.7%. For soccer, 1.11 for average bounce height and the bounce efficiency is 74%. For netball, 1.22 meter for average bounce height and the bounce efficiency is 81.3%. For volleyball, the average bounce height is 1.19 meter and the bounce efficiency is 79.3%. Same drop height that we used from the previous result. This is the calculation for table 2. Same calculation method as previous results, which is we have to find the value of average bounce height for each of the ball and the bounce efficiency for each of the ball. And these are the values that we got from the calculation. These are the graphs based on result in table 2. The first graph is average bounce height versus type of ball for outdoor temperature. The second graph is bounce efficiency versus types of ball for outdoor temperature. Next result is to analyze the material composition. For tennis, the material used are rubber core and are covered in a felt material made of nylon and wool. For soccer, synthetic leather outer layer and a rubber or latex bladder inside. For netball, leather or synthetic rubber with a textured surface, while volleyball use synthetic leather or natural leather with a rubber bladder inside. For weight of the ball, tennis and volleyball has a light weight, while soccer and netball are heavy weight. Based on the result, netball has the highest value of average bounce height and the highest value of bounce efficiency for both of the temperature. So why did this happen? This happened because of 3 factors. The first one is pressure and the bounce height. When the air pressure in the ball is higher, the compression is bigger. The internal pressure in the netball is 8.6 psi. So when the pressure decreases, the rebound from the ground will reduce, although there is no change in the structure. The ball throws greater potential energy when compressed upon impact. this energy is released more effectively with optimized pressure. As the ball hits the ground, kinetic energy is converted to elastic potential energy. Next factor is material composition for each of the ball. The internal pressure for tennis is 26.5 psi, which makes tennis internal pressure higher than the netball. But how does netball have the highest ball frequency? A material such as rubber is very elastic, hence allow the ball to convert the potential elastic energy into elastic energy, subsequently bounce easily. Netball is made of leather or synthetic rubber with a textured surface, which makes this ball less elastic but transfer energy perfectly with the impact. However, tennis is made of rubber core and is covered in a felt material made of nylon and wool, which absorbs more or some of the impact energy. As a result, netball has higher bounce efficiency than tennis, even though tennis has higher internal pressure than netball. The third factor is temperature change. Based on the result in table 4, the average bounce height at outdoor temperature has higher value than indoor temperature for each of the balls. This is because temperature increases, the kinetic movement of gas molecules become faster, which makes the tendency of the molecule to collide with each other is higher. This also will creating a force that allows them to rebound. When the temperature increases, the speed of the particle increases according to the kinetic molecular theory. In contrast, when the ball's temperature falls, the gas molecule moves slowly in the ball, causing the ball to bounce not as high as before. This study to determine the factors that influence the bounce height and the efficiency of various balls, which make netball has the highest average bounce height and the bounce efficiency. The key factors affecting this result include internal pressure, material composition, and surrounding temperature. The finding highlight the higher internal pressure could increase bounce height and the importance of material properties such as those of leather and synthetic rubber in sports equipment performance. This study offers valuable insights for manufacturers aiming to optimize the ball design for specific sports and assist individuals in selecting suitable sports based on environmental conditions. For example, choosing the right sports to play during hot or cold seasons. Future research is suggested to further examine external factors affecting bounce characteristics. Based on the result of our experiment, the data support our hypothesis. The observation of the internal pressure, material composition, and the temperature align with the expected outcome.